Hey guys, welcome back for part 2 of the scientific method video lectures. This is where we left off last time at step 2. So we've made an observation and we have asked a question or identified a problem. And so our next step is going to be to write a hypothesis or formulate a hypothesis. But I also mentioned to you that we need to understand about variables. So that's our next, that's the next thing that we're going to talk about. That's the subject of this video. Okay, so in science experiments using scientific method, there are 3 categories of variables. Now, a variable, if you look at the word variable, if you look up here, it actually has the same word, same word root as like variety and vary. Vary means to change. V-A-R-Y means to change. Variety, you guys know what variety is, like you have a lot of different choices. So we call them variables, but variables are actually factors or parts of your experiment that have some effect or is the effect or the cause of something happening in your experiment. Okay, and there are 3 categories of variables. The first one are independent variable. Okay, the first one is independent variable. We often just abbreviate that with IV. So you see here the capitalized IV. That stands for independent variable. Now, the independent variable in an experiment is the one factor that the scientist changes. Okay, and so if you are the scientist, if you're doing an experiment, if you're trying to answer a question or solve a problem using scientific method, you as the scientist are going to choose the one factor that you change. Now, this is the factor that you think is causing something to happen in the natural world. You think that this is like key to understanding the answer to your question. Now, if we go back to the root beer, the diet root beer experiment, in this experiment, our independent variable is going to be the cooling method. So I'm going to use multiple cooling methods. Let me turn my camera off for just a second. Okay, so we're going to have a refrigerator freezer. So I will put 1 can of the soda in the freezer. I'll put 1 in the refrigerator, and I'll put 1 in ice, just like a container or bucket of ice. And then the other one I'm going to put in a bucket or a container that has ice, water, and some salt. Okay, so that is what the scientist, that is what Miss Yu, the scientist, has chosen as my independent variable. That's the factor that I'm going to change to help me answer my question or solve my problem of not having soda that's cold enough. So I want to figure out which one of these cooling methods is going to get my soda as cold as possible in a short amount of time without freezing it. So my independent variable for this experiment is the cooling method. All right, the next one that we have to look at, the next variable type that we have to look at is called the dependent variable, and we often abbreviate that with the DV. So you see the capital letter D and capital letter V. Okay, so the dependent variable is the factor that changes because of the independent variable. And we often, the dependent variable is almost always going to be your result or the outcome. So in this case, in the diet root beer experiment, our dependent variable is going to be the temperature of the root beer after the procedure. So remember, we said the independent variable, the thing that I as a scientist am going to change, is the cooling method. So sometimes 1 can is going to go in the freezer, 1's going to go in the refrigerator, 1's going to go in ice, and the other 1's going to go in a salt, water, and ice bath, basically. Okay, so that's my independent variable. So what am I hoping to, what kind of data am I trying to collect? What kind of information am I trying to collect? I want my soda to be really cold. So I need to measure the temperature of the soda after being in each one of those cooling methods. So the dependent variable for this experiment is the temperature of the root beer. So I will use a thermometer and I will put it in each can after a certain amount of time. I'll take that out of the refrigerator. I'll take the one out of the freezer. I'll take the one out of the ice. I'll take the one out of the saltwater ice bath, and I will use a thermometer and measure the temperature of each one of those. So that's the data that I'm collecting, and that is the dependent variable as well in this experiment. Okay, the next type of variable is plural. You notice the little s here? That's because there's always more than one. Sometimes there's a lot. And then we also abbreviate this as CV. So when you see CV, that stands for control variables or controlled variables. Sometimes they do the CONTROLLED. So you'll see it either way. It's the same thing, control variables or controlled variables. Now, these are any other factors that might affect what happens in your experiment, how it affects the subject. For example, in this case, the cans of soda, the cans of diet root beer, those are my test subjects. Those are my test groups. And so I have to think about any other variable that might affect like how cool they get or how they don't get cool, things like that, okay? And so in this experiment, in the diet root beer experiment, my control variables are things like, here, let me turn the camera off again. So there are things like the starting temperature. So I don't want to have one can of soda be, like room temperature, just sitting out on the table in here, and one already be in the refrigerator, and one maybe was sitting in my car in the hot boiling sun. It doesn't matter which one of those we start with, but all of the sodas that we use in the experiment as test subjects, all of them need to start out at the same temperature. So as long as they're all like been in my car in the sun, or they've all been in the refrigerator, or they've all been sitting out on the table at room temperature, we want to make sure that that factor, their starting temperature, is the same. Another control variable in this experiment is the type of soda. I don't want to use like A&W diet root beer and Mug diet root beer and Barks diet root beer. I want to use all one type. And in this case, I'm going to use the A&W diet root beer. I also don't want to use diet root beer and Diet Coke and Sprite and Orange Slice. I don't want to use different kinds of soda. Okay, so one of the factors that we need to control, one of the control variables, is the type of soda. Another thing that we need to control, another control variable, is the type of soda container. Even if we're using all A&W diet root beer, if I use some in a can and some in a plastic bottle and some in a glass bottle, that's no good, okay, because that might have something to do with how quickly they cool down as well. So I want to make sure that the type of container is the same. I also want to use the same length of cooling time. I don't want to leave the one in the freezer for 35 minutes and the one in the refrigerator for only 20, and the one in the ice bath for 15, and the one in the ice water salt bath for, like 40 minutes. So the length of time that I leave those test subjects in the cooling method also needs to be controlled. So these are examples of control variables within this experiment. Okay. So our next topic is going to be writing a hypothesis, and I wanted you to understand variables before we get into writing a hypothesis. Okay, so let me go back so you don't like freak out and start trying to write everything down you see on the screen. And that's another thing. If you wrote every word that was on the screen, you're kind of wasting your time. So we're going to talk about how best to write notes on this, and also that you will have access to this presentation, not just the video. Okay, so we're going to stop there. We talked about independent variable, dependent variable, and control variables. The independent variable is the one that the scientist changes to test. The dependent variable are our results or outcome. That's what we're looking to see the independent variable causing. And then the third is the control variables. Those are any other factor that might affect the outcome of our experiment. All right, we'll be practicing this in class, so I hope you learned a lot. Thank you.